exponential function, right? Okay. Is it the parent? How many parents are there in exponential functions? There's a lot, right? There's 2 to the x, 3 to the x, 4 to the x, and so on. Okay? So is this a parent? Yes. Okay? So you already know all the rules of transformations. I'm not teaching you anything new today. What I need to make sure you understand is anytime we talk about transformations, we always talk about inside or outside, right? That helps us know if it's horizontal change or vertical change. I just need to make sure you understand where inside is and where outside is. Okay? So if we have y equals 2 raised to the x power, and I put a plus 3 right here, tell me, is that inside or outside? Well, one of those is right. This is inside because we're talking about inside the exponent, right? Okay. What if I put this then? That's outside, right? So tell me what kind of changes this has compared to its parent, which was this, right? What kind of changes does it have? And what? Try again. Thank you. Does that make sense? Now, can I show you a problem that some people have had today? Okay, here's the problem. What kind of changes does this have to its parent? The bases are not the same as this, right? But what changes are they compared to its parent? Exactly the same, right? A horizontal shift left 3 and a vertical shift F5. But some people think they're different transformational changes because the bases are different. Are they a different transformational change? No, they're the same transformational change. It's just that they started different. This started 2 to the x, this started 3 to the x. But all the transformation rules that you know still apply, which means this is still a horizontal shift left 3 and a vertical shift up 5. Are you okay with that? Okay, so do I need to go over all of the things that we do, or do you remember all of the transformational things that we have? Plus, it's on the top of your worksheet, right? In case you need to have that. All right, then let's talk about logs. Y equals log of x. That's a weird G. I'm sorry about that. What's inside or outside here? Is this inside or outside? Outside. How do you know? Because that's inside, right? What kind of a change is this? Vertical shift. This is a vertical shift. Up 5. And what kind of change is this? Really? Left 5, right? What other changes are we going to have to deal with besides horizontal shifts and vertical shifts? Vertical stretches and compressions, horizontal stretches or compressions, and one more? Reflections. Okay? Can I remind you of a couple of those? If there's a negative on the outside right there, what does that cause? Reflection over the x-axis. What if it looks like y equals log of negative x? That's a reflection over the y-axis, right? What if it looks like that? Vertical stretch. By a factor of 2. Can I try to trick you? Y equals log of 2x. Is it a stretch or compression? Oops. By a factor of 1/2. Reciprocal, right? Remember that? Okay. Any questions? Is any of this new? Kind of. I agree with kind of, right? Because we've done transformations of quadratics and of square roots and of cubes and of cube roots and of rational functions and of absolute value functions. And now we've got exponentials and logarithms. So we haven't done exponentials and logarithms before, but we've done all the other stuff. So we're taking the knowledge from all the other stuff and we're putting it with exponents and logarithms. You okay with that? Okay.